Given the linear programming problem, minimize z is equal to 0.3x1 plus 0.9x2, subject to the constraints x1 plus x2 is greater than or equal to 800, 0.21x1 minus 0.30x2 is less than or equal to 0, 0.03x1 minus 0.01x2 is greater than or equal to 0, and x1 and x2 is greater than or equal to 0. I am going to find the optimal solution for this problem. To do this, I will click on Task and go to Optimize, and check this box and go to the problem based, which is the recommended one, and click there. I am just going to put this problem here in the corner here so that I can continue to see it. I'm going to start by defining the variables, which are x1 and x2. The first variable is x1. It's a one-dimensional continuous variable, which is bound by 0 as shown here. So I'm going to put a 0 here. And I'll leave the upper bound and the initial point as they are. To add another variable, click on this sign. The second variable is x2. It's also one-dimensional and it's continuous. And the lower bound as shown here is 0. And we'll leave this as they are. I now move on to defining the problem. As shown in our problem here, our goal is to minimize. So we'll click here, which is already clicked anyway. If it were a maximizing problem, I would click here. I go on and enter the objective function, which is the z, which is here. My z is equal to 0.3x1 plus 0.9x2, 0.3 times x1 plus 0.9 times x2, and add the constraints. The first constraint is this one here, x1 plus x2. This is greater than or equal to 800. So I'm just going to change this sign here. Go on the drop down. It's greater than or equal to 800. To add another constraint, click here. This is the second constraint. It's 0.21 times x1 minus 0.30 times x2. This is less than or equal to 0, so we'll just leave this as it is and put a 0 here. Add the last constraint, which is this one here, 0.03 times x1 minus 0.01 times x2 times x. This is greater than or equal to 0. Put a 0 here. Then just click the results that we need to be displayed. We need to show the problem, we need to show the solution, the reason solver stopped, and the objective value. So we'll leave all these checked. I now move on to solve the problem. Scroll up and then click on Run. Scroll down to see the solution. We are solving for x1 and x2 given these constraints. Our optimal solution is z is equal to 437.6471. This occurs when x1 is equal to 470.5882 and when x2 is equal to 329.4118. Thank you.